Alright guys, so today we're going to be learning about factoring when we have a leading coefficient that is a prime number. So you've just been doing ones where it's just x squared plus bx plus c, and there wasn't an a term out front, but today we're going to throw in that a term. So these are the conditions we're factoring under. So it has to be a degree 2, meaning it has to have an x squared. It has to be a trinomial, meaning it has to have an x squared term, an x term, and just a constant. And it has to have a leading coefficient where a is a prime number. So this can't be like a 4 or a 6 because 4 is 2 times 2. So it's got to be like 2 or 3 or 5 or 7 or something like that. Today we'll do prime, and then tomorrow we'll throw in where this guy could be anything he wants to be. Okay. So firstly, let's talk about, again, going back to the distributive property, where these terms actually come from. So you just learned the Curious George method, or you might just be distributing, but we know that we multiply these two first terms together, and that's where our a term comes from. When we multiply those together, that gets us our 2x squared. Then we multiply these two last terms together. That gets our c term. That's our plus 9. But this b term in the middle comes from both this guy, which is a 3x, and this guy, which is a 6x. Those two things added together become our b term. So 3x and 6x together become a positive 9x. So the reason these questions are slightly complicated is because that inside and outside multiplication, I've got to worry about the combinations to see what they add up to be. Okay, so to factor, we're going to look at a couple different things. We're going to look at our a term, and we're going to say, what are the possible factors for my a term? So my possible factors here are a 3 times a 1. I'm going to look at my c term, and it's got to be in descending order. And I'm going to look at the factors there. Well, the factors of 4 are either 4 times 1 or, I'll just squish it to the side here, 2 times 2. So I've got a couple different combinations to set up. And so I'm going to show you how to go through those combinations. So real quick, I'm going to do it just quickly, and then I'll show you step by step how to do each of them. Well, my a term comes from the first term in both binomials. So this was like a 2x times x gave me 2x squared. Well, how do I get 3x squared? There's only one way. It's 3x times x. So I'm going to go ahead and write 3x and x. So the a term today being prime makes it easy. There's only one option. You write both answers. But this c term could be a 4 and a 1, or a 4 and a 1, or a 2 and a 2. So there's really 6 different combinations, including signs. So if you want to, you can write them in with a pencil and erase it, but I like to just write down all the combinations. I like to start with the not extreme ones, like the one that has a 1 on it. I like to start with the closer together ones. So I'm just going to put a 2 and a 2. There is no need to check your a value. I don't need to check 3x times x gives me 3x squared. I don't need to check 2 times 2 gives me 4. Those should always be stuck. But check your inner and your outer. Those little, the mouth and the nose, whatever, of George. So that's a 2x, and that's a 6x. Well, can 2x and 6x give me a negative x in any form or fashion? No, that's not possible. So 2 and 2 is not an option. Normally we swap places, but since they're both 2's, this guy does not work at all. So then I would go ahead and I would try it again. So I would just say 3x and x, and then just try whatever combination you want to. So I'm just going to go ahead and put a 4 and a 1. Okay, check your outer and your inner. 4x is 4x, 3x is 3x. Can 4x and 3x give me a negative 1? Well, yes, if I have a negative 4x and a positive 3. Well, how did I get a negative 4x? Well, that's 4 times x. That's a negative 4 times x, which makes this guy positive. So in this one, we had to guess and check just 2 times. Once you get better at these, you can usually kind of spot one that's not going to work, and you can get to a little quicker. Also, by leaving the signs off until the very end, you eliminate having to try like 2 guesses. You can just guess one set of numbers and then just look at those signs. So let's go down here to the bottom and look at each step individually and work through them slowly. All right, so let's go ahead and work an example much slower explaining all the steps. Okay, well, step one is always check for a GCF. No matter what you're factoring in any form or fashion, if there's a GCF, you want to get rid of that first. So going over here to our example, are there any variables shared? Well, no, this guy has no variables, so there's no variables shared throughout. Do these share any numerical factors? Well, 3 doesn't go into 13 or 10. The factors of 3 are 3 and 1. So no, there is no GCF. But always check for GCF first to make sure that your problem is a little easier on yourself. Okay, next we're going to find your factor pairs for A and C. Well, on your problem, go ahead and find your factors of A and your factors of C. So I'm going to go up here to my example, and what multiplies to be 3? Well, that's only 1 times 3. What multiplies to be 10? Well, that could be 1 times 10 or 2 times 5. So I do have a couple different combinations there as opposed to just one. Okay, then we are going to guess and check until you find a combination that works. So you just got to use your brain, try your best to eliminate obvious answers, but sometimes they're not so obvious. You just got to work your way through the list. But today our leading coefficient is prime, so this very first part is always going to be easy. So I'm going to go ahead and set myself up two binomials rather. I have to have, the only way to get 3x squared is to have 1x times 3x. Doesn't matter what order you put it in, so I'm just going to write the way I said it, 1x and 3x. Does not matter at all which order. If you like to write down and erase repeatedly, have at it, but I'm going to keep writing it down, writing it down, writing it down. I've got plenty of space. Okay? I said I like to usually start with the 2 and the 5, but I want to start with 1 and 10 so you can see a couple things that happen. So I'm just going to go ahead and put 1 and 10 in there. All right, so I'm going to check my inner and my outer products here. So 1 times 3x is 3x, and 1x times 10 is 10x. Okay, so on the last question, I didn't talk about signs a lot just because I was trying to go through an example really quickly. But on this problem, can 10x and 3x give me negative 13x? Well, the answer is actually yes. If I had a negative 3x and a negative 10x, I would get negative 13x. But this guy is a negative 10. So the only way to get a negative 10x and a negative 3x would be to have a negative sign here and a negative sign here. But does negative 1 times negative 10 give me negative 10? No. So in this case, the middle numbers actually do work out, but then the outer numbers no longer work. So you've always got to kind of keep an eye on this negative or positive sign to know whether you should have a positive and a negative, or both negatives, both positives, whatever. So in this case, I know that I have to have one negative and one positive. So therefore, this example does not work. So I'm just going to go ahead and that guy doesn't work. Okay, I'm going to go ahead and change colors, I guess, make it a little easier. So I'm going to do the exact same thing again. And I like to always exhaust a number set. So if I chose 1 and 10, I'm now going to choose 10 and 1. I always want to try it fully out so I can make sure it does not work and I can cross it off my list. We'll check your inner and outer. Well, 10 times 3x is 30x, and 1x times x is just 1x. Well, can 30x and 1x give me 13x? No, it can either give me 29 or 31. There's no way to make that guy work. So this guy, boom, don't even worry about signs. He's completely wrong. So let's go ahead and try another one. And there's only, 4 combinations, really. So 1x, we're almost there. We might get it right this time, we might get it wrong. I don't know. All right, let's go ahead and just try a 5 and a 2. Okay, check your inner. That's going to be 15x. Check your outer. That's going to be 2x. Ooh, this looks promising. Can 15x and 2x give me a negative 13x? If so, how? Well, I know I need to have a positive and a negative in order for that to work. So I want a negative 15x and a positive 2x. Because negative 15 plus 2 is negative 13x. Okay, well, how do I get a positive 2x? Well, I multiplied on this outer product, which means the sign must go with this outer product. 1x times positive 2 is positive 2x. Well, how do I get a negative 15x? That comes from my inner product. So the sign must go to my inner product. So negative 5 times positive 3x is a negative 15x. At the very end, once you think you have your answer, I would always just double check everything just to be sure. 1x times 3x is in fact 3x squared. Let's double check our inner product again. Negative 5 times 3 is negative 15. 1 times 2 is a positive 2x. Negative 15 plus 2 is in fact negative 13. And lastly, is negative 5 times positive 2 in fact negative 10? Yes. So then my final answer is just this product here. So always make sure you check for this sign especially, but check for signs at the very end. You can always just multiply this back out and check your answer again.